All right, so we had a malfunction with the phone. So we're going to run through this one more time so we don't have to post 3 videos. What we're doing here is we're building the circuit. So we got what our A naught runs through the inverter, B naught goes through the inverter, C naught goes through the inverter. So we take X and it equals A naught. So I'm just going to draw A naught all the way across, put an X. That's my output. Then I'm going to build the Y. So I got A naught again coming in and ANDed with B. And then I got B ANDed with C naught. And then both of those outputs are ORed together. And that gives me my Y output. So now I can build my Z circuit. So Z says A ANDed with B naught. So I'm going to take my A. I'm going to bring it all the way down here. Oops, that's a little crooked. And I'm going to bring that like that. And I got to AND it with my B naught. So I'm going to bring my B naught straight down, put it here, and I'm going to AND them together. Now, the good thing here is you guys actually have a chip, I believe it's 7411, which is a 3-input AND gate. So you could use that, or you can use 2 more AND gates there. I would use the 3-input AND gate, because either way you're going to have to put another chip in your board because you're only left with 1 AND gate. And just remember though, the truth table for a 3-input AND gate, the only time you're going to get a 1 is if all 3 inputs are a 1. If it's not that way, you're going to get a 0 out. So I'm actually going to build a 3-input AND gate here. So we're going to use A naught. I know this kind of looks a little crazy, that's why I'm using different colors. There's 1 input. B, so we'll bring our B down, and what I'm going to do is I'm actually going to bring the B off of here, bring it down, makes it less confusing. And then I got C, and I'm going to do the same thing with C. I'm just going to bring the C off of here. And then I can draw my AND gate. Now, both of these outputs go to an OR gate because they're ORed together. So draw my OR gate, and that's my Z answer. Now, you can go back in and you can say, okay, if A is 0, B is 0, and C is 0, you can do the logic and figure out what your output is. Do I care? No, because I had all X's there. So I really don't care what the output is for 0, 0, 0. But you can go back in and see what it would come out to be. Then you go to 0, 0, 1. So you put 0, 0, 1 in here and see what we got. Well, let's do 0, 0, 1 just to check it. You guys can go through and check the rest of these. So if this is 0, then A naught is a 1. If B is a 0, is a 0. B naught, I can't hold all these markers. B naught is a 1. And if C is a 1, C naught is a 0. So now we can go through and we can put it in. Well, we got A naught coming here, so we got a 1 on here. And we got B coming, so we got a 0. Well, 1 and a 0 into an AND gate gives me a 0 out, so I got a 0 going in there. So let's go to my next NAND gate. Well, I got a 0 coming in here because it's a B. And then I got C naught coming in, which is a 0. 0 and a 0 in gives me a 0 out. 0 and a 0 into an OR gate gives me a 0 out. And since we now got Y, we'll put X in there. Since X is equal to A naught is a 1. So I got a 1 out there. Now I got to do Z. Well, I have A coming in, which is a 0. And I got B naught coming in, which is a 1. A 1 and a 0 gives me a 0. So I got a 0 going in there so far. Now I got my 3-input AND gate. So I got A naught coming in, which is a 1. I got B naught coming in, or B coming in, sorry, which is a 0. And then I got C coming in, which is a 1. But remember we said the only time we get a 1 output is if all 3 inputs are a 1. They're not. So I get a 0 out. A 0 and a 0 into an OR gate gives me a 0 out. So I got a 0. So I should have had 1, 0, 0 when I put in 0, 0, 1. 0, 0, 1 gives me 1, 0, 0. So it works. And you guys can go through the rest of them. You don't have to do 5 if you don't want, because we don't care. So we don't care what it is when we put 1, 0, 1 in. But I would do them all just to check and see. And that's how we build the encoder. The next video, we're going to talk about building the decoder for this. Goodbye.